Cognigy Script is a fun and powerful feature that allows developers to add TypeScript or JavaScript to their flows. Cognigy Script isn't a language unto itself. It adds Cognigy-specific objects to standard TypeScript or JavaScript. This video is the first video in our training series to require a developer skill set. I'll assume that you're comfortable working in a code editor and working with JavaScript and object-oriented syntax. We won't spend much time in this video actually writing code together. There will be code samples provided to accompany this video, and you'll find more in the Cognigy documentation and GitHub. What I'll focus on is where you can use Cognigy Script and common use cases for it. We've seen Cognigy Script already. Even though we haven't written any logic, we've used Cognigy Script to reference objects like the input, context, and profile objects. Anywhere we've entered double curly braces, we've been using Cognigy Script. Cognigy Script permeates the product and can be used almost anywhere. Let's look at a few examples. I'll create a new flow, and I'll create a say node. I'll greet the user and either say good morning or good evening, depending on the time of day. Note that Cognigy Script in node arguments is always returned as a string, unless you force the type to be preserved. You can do this by appending preserve type to your script. In this case, it just means that the code executed within the curly braces will return a string. We can also add Cognigy Script to galleries and quick replies. I'll create a gallery that shows one card if it's before noon and another if it's afternoon. Note that I'm using CI here instead of input. Prior to this session, we've used input, context, and profile to reference values in those data stores. We can do the exact same thing with CI, CC, and CP respectively. It does the same thing, but with fewer keystrokes. The nice thing about Cognigy Script is that it gets you complete flexibility in how you converse with your users. But it has a side effect of putting code into a low-code platform in a way that won't make sense to non-developers. One way to deal with packaging up your code in a user-friendly fashion is Cognigy extensions. We won't cover that in this session, but I encourage you to review the documentation in our Help Center. A convenient way to do this on a small scale is with tokens. Tokens are small snippets of Cognigy Script that can be made available in a user-friendly way to non-technical flow developers. We've actually been using tokens throughout the course. Things like last question result or first slot match are built-in tokens, and you can create your own. Let's do that. We can take our greeting as an example. It's complicated for a non-technical user to understand the Cognigy Script, but it's something they might want to use in different flows. To create a token, go to the left bar and select Manage and Tokens. Click Create New Token and name it Greeting. In the Script field, we'll put some Cognigy Script. For the type, this just indicates where it will be grouped in the token drop-down list. I'll choose Custom. Tokens are a great fit for adding dynamic content where the logic won't change much over time. If you think about the last question result token, that's referencing the Cognigy input, and it's a built-in feature of the platform. so it's a great use for tokens. The reason I highlight this is that the token value is copied to the field where it's inserted. This happens when you save the node where the token is used. You can't make subsequent updates to tokens. You can only delete them. If you do delete a token, changes won't be made to the nodes where you've already used the token. What if it would be really helpful to have a token, but you also want to make some changes to it over time? An option would be to keep the logic in the token, but the data outside of the token. For example, if you recall in a previous session, we worked with a lexicon of items that you can or can't bring on an aircraft. I added data to the lexicon to indicate whether you could bring the item on board and added additional information if one was required. Let's make a token for our flow developers that lets them add this logic to a flow. If there is a slot match for the item the user wants to pack, we'll output a message like we did in the previous session. If there isn't a slot match, we'll output a message asking the user what they want to pack. The catch is that this message might change over time. In the summer, we might give users ideas for items like sunglasses and sandals, and in the winter, we might ask users to think about packing skis and gloves. Here's what we can do. We can store the message in the default context, a topic we haven't covered yet. The default context is a set of context values that are available automatically when a conversation is started. In other words, they let you pre-populate the context. You can access default context values like any other context value. To find the default context, go to the top of the flow editor and select Settings. Then click on the Default Context subtab. I'll add a message to the default context. And save. Now I'll create a token by going to the left bar and selecting Manage, then Tokens. For my token, I'll enter the following as my script. I'm just checking to see if there's a slot match, and if so, outputting the explanation. If not, I'll output the missing slot message. I'll save it as a custom type. And I'll save. Now I'll return to my flow. I'll delete our work so far so we can start with a clean slate. I'll create a say node and add my packing token, and save. The last thing I need to do is attach my pack lexicon to this flow and build. Now we can test it out. I'll first just say hi, and it outputs the missing slot message. And it outputs the explanation. If I wanted to change the missing slot message, I can do that at any time by changing the default context. This is an interesting approach, but is it a good idea? If there is fairly consistent logic that you want to put in the hands of a flow developer, even yourself, using tokens, this could be a good idea. It lets you package up some logic while letting you manage any changing data. As I mentioned earlier, the only shortcoming of any token is that it can only be deleted, not updated. Let's change topics and talk about if nodes. In if nodes, I can use Cognigy script to create more complex conditions than the rule builder can handle. Let's tackle something we've seen throughout the training: Cognigy recognizing certain English language words, such as the, but, can, art, ask, ash, and fly. I'll attach my airport lexicon and build, and we can try it out. I'll delete the nodes we've created so far. What if the conversation went like this? The bot asks, "What is your destination airport?" And the user says, "Can I ask if the airline will fly to SFO?" Cognigy finds 5 slot matches, and there aren't any obvious rules that would tell us which one is the destination airport. One way to address this is to flag the ambiguous airports in the lexicon. I'll open the airports lexicon. I'll search for can, C-A-N. I'll click the down arrow on the right side and I'll add ambiguous, true. Now I'll go back to my flow. Since I changed my lexicon, I need to go to the NLU tab, then click Build Model. I'll go to my chart and add a question node. I'll open it and ask, "What is your destination airport?" I'll make it a slot question and enter airport code as my slot match. And I'll save. Now I'll add an if node. I'll open it and check for 2 things. First, I want to see if there are multiple slot matches. This would be true if the user mentions an ambiguous word along with a valid airport code. Second, even if there is one slot match, I want to see if it's an ambiguous one, and if so, confirm with the user. I'll click on Use Advanced Editor, and I'll add the following condition. In my Then branch, I'll add a Say node and make it say ambiguous. On the Else branch, I'll add a Say node and make it say Not ambiguous. Now let's test out a few scenarios. First, the happy path. Now with multiple slot matches. And now with an ambiguous slot match. In general, you can include Cognigy script anywhere you find a text or data field in Cognigy. In prior sessions, for example, we've looked at other places you can include Cognigy script, such as HTTP request nodes. For more complex logic, we'll introduce a new node type, the code node. Code nodes are exactly what they sound like. They enable a flow creator to execute custom JavaScript or TypeScript code within the flow. The code editor has full IntelliSense and exposes all Cognigy objects and actions. The execution of the code node is synchronous. The flow will continue after the code node has finished executing. Just as within other nodes, input, context, and profile can be accessed and modified within code nodes. When I open a code node, I get an editor. It's helpful to expand the edit panel to give yourself more room to type. The Actions object provides access to most internal node functions within the code node. Actions expose static methods like output, add to context, think, and update profile. Note that code nodes don't support imports. You're limited to what's available by default in JavaScript or TypeScript. Cognigy does include several libraries: the Moment.js module for parsing, validating, manipulating, and displaying dates, the Lodash library for working with arrays, the Facebook Bot Messenger module for building Facebook templates, and the XML to JS library for parsing XML data. As developers, when we discover code nodes, our inclination is to think, great, I'll do everything in code nodes. Code nodes are powerful, flexible, and require less clicking, so why not? The balance we need to strike as developers is between the efficiency of writing code and the transparency of the graphical editor. If there are non-coders who will be maintaining flows, we should limit code nodes to executing more complex logic, while using the other node types for what they're designed for. So a non-coder shouldn't have to open a code node to make changes to an actions.output method, for example. They should be able to do that in a say node. The same is true for basic branching with lookup nodes and if nodes. I recommend code nodes for situations where you need to dynamically generate text replies, quick replies, or galleries, process the results of HTTP responses, search the context, or parse dates. These are things that aren't easily achieved in other flow nodes, but are easy to do in code. Let's look at an example that combines a number of these. We'll request flight data from Aviation Stack as we did in a previous session. When we get the results back, we'll check for flights that haven't landed yet and output quick replies to let a user choose to see detail on a specific flight. To get us started, we'll work with the simple flow I've built. Think of it as an excerpt from a conversation with a user checking on the status of their flight. To simplify the flow, I'm using a Cognigy extension. The first node, Fill Aviation Slots, handles the different ways a user might ask about their flight status. So they could say, I'm traveling from SFO to ORD, or I'm traveling to ORD from SFO, or I'm leaving SFO and arriving in ORD, or any number of other permutations. Then there's a question node that asks what airline the user is flying on. I have it set to skip if answer exists in context. In my example, the answer will exist in the context because I've already created an airline slot filler. I have a say node that just confirms the user's choices. And finally, I have another extension node that retrieves all flights today on the user's preferred airline, departing from the departure city and arriving in the arrival city. This data comes directly from Aviation Stack. I'll test it out by saying I'm traveling from SFO to LAX on United. The flow executes and I get some data back in the Cognigy context. I'll copy this over to JSON Pathfinder and take a look. If I expand schedule, then data, you'll see I get 8 results. I'll open the results and see that there's a flight status field. Some of the flight status fields say scheduled, and others say landed. For the ones that are still scheduled, I want to give the user the option to get more details about the flight. Step 1 will be to get all of the flights that are in the scheduled state. To do this, I'll use the built-in Lodash library. I don't have to do it this way. You can use your preferred approach in JavaScript or TypeScript, but Lodash can be a fun and efficient way to work with arrays. The filter method returns all of the flights with the scheduled flight status. I want to dynamically generate quick replies for each flight with a payload that is the flight number. I could do this by creating an object that follows the format required for the out-of-the-box web chat client. But again, for fun, let's use another built-in library, the Facebook Bot Messenger. I'll use the message builder to create the message for my default channel so we can see it in the web chat. Let's test it out. We can see it outputs the quick reply. I want the user to be able to click on the quick reply and get the flight details, and the easiest way to do this would be through a question node. But I can't create a question node using the API in a code node, so I'll just add a wait for input node underneath my code node. When the user clicks on a flight, I'll look it up and output the flight details. I'll create a code node underneath my wait for input node. I'll open my code node, and the first thing I'll do is search for a result. I'll use the Lodash library again. Now I want to display the flight detail using the Adaptive Card plugin. This gives the user a nice visual output, which we'll see in a minute. The plugin expects an object that describes all of the formatting and data needed for the card. I'll just paste it in. I've used my flight detail object to populate values within the card. Let's take a look. I'll go to the left bar and find Deploy, then Endpoints. I'll select my web endpoint and open the web chat. I'll say I'm traveling from SFO to LAX on United. And then I'll click on the flight. And I get this nicely formatted card. One shortcoming of the card is that the departure and arrival dates aren't in a user-friendly format. I really just want the time. So let's go back to my code node. I'll use another built-in library, Moment.js, to format my date. Again, you can use standard JavaScript or TypeScript to accomplish the same thing, but if you haven't used Moment.js before, it's fun to check out. I'll add some code to change my departure and arrival times. I'll save. Now let's go back to my web chat and test again. I'll say I'm traveling from SFO to LAX on United. And then I'll click on a flight. And now I see the times in the format I want. As a whole, this is a good example of when to use code nodes. There's really no way to accomplish what we've just done using a flow, and the logic is too complicated for a non-technical user. So we can solve the problem in code nodes without guilt. I recommend adding labels or comments to your code nodes. So for example, in my final code node, I'll open it, and under styling, I'll put Adaptive Card. And for my comment, I'll put looks up selected flight and outputs adaptive card object. As a final note on this example, in real life I'd want to do some checking to make sure I get results back from the initial query, to make sure there are in fact scheduled flights, and to make sure the flights that the user selected is on the list of scheduled flights. So standard checks that we haven't done here for the sake of expediency. I hope you appreciate the power of code nodes and enjoy using them. If you start putting a lot of logic into a single code node, consider creating a Cognigy extension. You can learn about extensions in Cognigy's Help Center.